Today, let's talk about a new Python library called Navexa, and it's trying to fix something that is, let's be honest, one of the most frustrating things in AI right now, getting it to actually understand our documents. We're talking about teaching an AI to see the structure and the logic inside a PDF, not just, a giant jumble of words. Let's get into it. So, have you ever done this? You take a super detailed 50-page report, you upload it to a chatbot, ask a pretty simple question, and the answer you get back is either completely wrong or just weird. It's a super common problem. And here's the thing, the AI isn't dumb. It's just blind to the document's layout. It literally can't see the headings, the chapters, or how different sections relate to each other. It's kind of like trying to read a book after someone's ripped out all the pages and just thrown them in a big pile. And this slide just nails the core problem. On the left, that's the old way. Most tools just smash a PDF into this flat wall of text. All that valuable structure, it's gone. Poof. But on the right, that's the Navexa way. It actually preserves the document's logic by turning it into a hierarchical tree. You can think of it as giving the AI a proper map or maybe an interactive table of contents instead of just that messy pile of pages. And this is exactly where Navexa steps in. It's built from the ground up to solve this specific problem, and it does it by treating the structure of a document as the single most important piece of information. So what is it really? Okay, the official description calls it a Python library for turning PDFs into a hierarchical tree and running reasoning-based retrieval. Let's just unpack that for a second. That hierarchical tree is the logical map of the document we just saw, but the reasoning-based retrieval, that's the secret sauce. Instead of just searching for words that sound similar, it actually reasons about where the answer should be within the document structure. It's a totally fresh take on RAG, retrieval augmented generation, but it does it without playing the usual word matching game. What's really cool here is just how versatile it is. Navexa isn't just for perfectly clean, structured reports. It actually has different game plans for everything from those well-organized documents to messy, unstructured text, and even meeting transcripts. And yeah, it can use an LLM for things like summaries, but its real power is that reasoning-based retrieval. That's what leads to what it calls grounded answers, answers you can actually trust. Oh, and for all you developers out there, it even has built-in cost tracking for LLM calls. A very nice touch. Okay, so that all sounds great in theory, but how does it actually do this? How does it take a boring old PDF and turn it into this intelligent, structured tree? Well, it's a surprisingly simple, elegant process. First, it just takes in the PDF. No surprise there. Then, and this is the really clever part, it analyzes the document to figure out what kind of document it's looking at. Is this a formal report with a nice table of contents? Is it a messy scan? And based on that analysis, it builds a totally custom tree that perfectly maps the document's internal logic. And this table right here really shows off that intelligence. Just look at how it changes its approach. For a structured document, boom, it uses the table of contents. For semi-structured ones, it can bring in an LLM to help clean up messy headings. For totally unstructured text, it just creates logical chunks. And for transcripts, it uses an LLM to group the conversation by topic. So you see, it's not a one-size-fits-all hammer. It adapts to whatever you throw at it. Now, building this incredible document tree is what unlocks Navexa's real superpower, a completely different way of finding information. This is a game changer. This is the key difference right here. On the left, you've got your typical vector search. It's basically a very sophisticated word matching game. It finds text that sounds like what you asked for. But on the right, you have Navexa, which acts more like a detective. It doesn't just look for matching words, it actually navigates the document's logical structure. It asks itself, okay, based on the table of contents and all these headings, which chapter, which subsection is most likely to have the answer to this question? It follows the context, not just the keywords. And that brings us to this really important phrase from the documentation, reasoning-based node retrieval and grounded answering. So what does that actually mean? Well, it means Navexa first reasons its way to the exact node, you can just think of that as a section, in the tree where the answer lives. Then it uses only the text from that one hyper-focused section to generate the answer. The result, you get an answer that is grounded in a specific, verifiable piece of text, and that dramatically reduces hallucinations and boosts accuracy. All right, so what does this all mean in the real world? What can you, as a developer, actually build with this thing? Well, you can take pretty much any document and turn it into that smart, logical tree. You can then run a query that reasons over that structure to find exactly what you're looking for. From there, you can pull out just that precise, hyper-focused piece of context and then use that to generate answers that you can actually rely on. It's really the whole end-to-end workflow for building trustworthy AI. And maybe the best part, it's designed to be incredibly easy to start using. For a developer, indexing a whole document is as simple as running one command in your terminal. That's it. And that kind of accessibility is so important for getting a powerful new tool like this into the hands of more people who can build cool things with it. So let's just end on this thought. Tools like Navexa really represent a pretty fundamental shift in how we think about this stuff. We're slowly moving away from just dumping a stream of text into an AI and kind of hoping for the best. Instead, we're starting to give these models the tools to actually understand context and structure and logic. So the question we're left with isn't just about getting slightly better answers. It's about what becomes possible when our AI doesn't just read our documents, but truly begins to understand them.